Hello everyone, this is chapter 1. In chapter 1 we talked about data management and wrangling. Data wrangling is a process of retrieving, cleansing, integrating, transforming, and enriching data to support analysis. So in this chapter we focus on 4 key tasks during the data wrangling techniques for a process. The first one is data management. The second one is data inspection, then data preparation, and data transformation. So after we've done data management, now is the time to go to data inspection. Data inspection, once the raw data are extracted from the database, we usually review and inspect the data set to assess data quality and relevant information for subsequent analysis. So in addition to visually reviewing data, counting and sorting data help us verify that the data set is complete. Counting and sorting data help us verify that data set is complete or that it may have missing values, especially for important variables. Sorting data is also allowing us to review the range of values for each variable. So in this section, we will be going over an example on how to inspect data through looking at the missing values, sorting data, and maybe counting, and look at the general theme of our data. So we have an example here. First of all, I have a markdown, R markdown file. I have 2 examples. I'm going to do the first example only, which is a question on the book, which is spend. A company conducts a survey of 500 consumers. The data file shows their home ownership, yes or no, car ownership, yes or no, annual household spending on food, and annual household spending on travel. We have a few tasks to do. First, we have to sort the data by home ownership, car ownership, and travel spending, all in descending order. After that, we will look at the first customer and how much they spend on food. For the second part, we are going to sort the data only by the travel spending amount in descending order. And out of the 10 customers who spend the most on traveling, how many of them are homeowners? Also, how many of them are both homeowners and car owners? After that, we are going to look at the missing values in each variable. Then we will look at how many customers are homeowners and how many customers are homeowners but do not own a car. Maybe we can add more parts and more questions to this. So the first important thing to do, number 1, is the solution. So this is marked down, right? So we need to add a subtitle. So solution. The first part, I'm going to load library and import the file. So we need to look at the file first. If you look at my files here, we have the data sets. I have it here. Remember, this is chapter 2 project. Right hand side, top right, chapter 2. So I'm working on the chapter 2 project. We have everything here. And remember that this is set as my working directory already. And our markdown file, and I have the Excel sheet that contains chapter 2 data sets. So first we have to call the library. Control or Command Option I. So I created a chunk. After that, I'm going to call the library. I'm going to make it easy. We don't have any file other than the Excel file, so that's why I'm going to call or load the read Excel library. After that, I'm going to call this one my data, then read XLSX. Then because my file is in my working directory, so I'm going to just copy the name, chapter 2 XLSX, comma, the second argument is going to contain the sheet, which is spend. So if I run the data, if I run the code, so I'm going to have my data here. Let's double click on this and let's look at the data first. So we have ID, we have own home. It's a character or factor variable, character, yes or no. Own car is another character variable. Food spend on food, and spend on travel. Those both are numeric variables. But again, to investigate more, it's recommended that you look at your data in general sense. So first, or second, let's say view data sets. Another chunk. You can write a view. I don't want to, view only viewing the data for you as we did. If you click here, it's going to view already. So there's no need to view this because this will not be able to to generate a PDF file once you finish. So there is no need to type in a view here. Let's look at the structure of the data, str of my data. So the data set now called my data. Let's look at the summary of the data as well. These are important functions. It's recommended that you look at these two functions, look at the sense of your data. So what do we have here? We have a table, 500 by 5. It's a data frame. We have 500 observations, and we have 5 variables. What are the 5 variables? ID, own home, own car, food spend, travel spend. And all of them we have from 1 to 500 observations. And what is the data type for the ID? It's a numeric. The second one's character, numeric, numeric. And these are the values that are taken by these variables. 1, 2, 3, up to 500, yes or no. And these are the numeric values taken by food spend and travel spend. You can look at the summary. The ID was the minimum values 1 expected, maximum is 500, makes sense. Homeowner, we have a character, so we don't have any classification here or any mode. It's a character, so we don't, yes or no only. The own car is yes or no, 500. We have 500 observations. For the food spend, for example, the minimum people spend, or this sample at least, 1,550. The maximum is 10,000. Maybe this is an outlier, we don't know, but maybe no. But we have to, this makes kind of, I don't know, weird. And travel spend, people, the minimum we have 637 and the maximum is 6,000. Makes sense. The range is making sense here. We have NAs, we have missing value, which is NA, right? So at least you have a sense of the variables. You know the minimum, the maximum. Then you can now answer the questions. So next question says, let me copy the first part. You can call this one part A, right? So sort the data by home ownership, car ownership, and the travel spending, all in descending order. So let's create a chunk first. We talked earlier about the functions that we were going to use. In this case, to sort, the best function to use is order. If you, first of all, because you want to sort the data, it's a good practice to create a new data set with the sorted data. So I'm going to call it sorted data. This is a new data set. It's going to be sorted. What I'm going to do, I'm going to go to my data, which is the data set, the file itself. I'm going to open the brackets. Because this is data frame, we're going to have 2 arguments or 2 numbers, because this is a table, data frame. So the first one covers the rows, the second one covers the columns. What I'm going to do, I'm going to use the order function, because if you use the order function, let me just go down there and just type in the console. Let me type order first. Order what? My data. I'm going to do my data on home. Then I'm going to look at the arguments. I'm going to say, is it decreasing? I'm going to say decreasing. I'm going to say true, right? Because descending order. Then I'm going to do enter. So we are ordering the cases. So the order give you the indices. The order function give you the indices. So the case that has the highest, hold on, home, no. Let me use numeric so it makes sense. Food spend. So the case number 313 has the highest food spend, or they spend the most on the food. The case 260, so these are cases, these are the observations. This is row 313, this is row 260, this is row 237. These are the rows, the whole row. So 313, for example, go down 313. 313, where is it? 313, look at spend on food, 10,000. By the way, this case is strange because they spend on food 10,000, they spend on travel just 700. So that's why I said maybe this is kind of an outlier, by the way. But this is the highest. Then 260 is going to be the second case, and so on. So the order function give you the indices, right? So we wanna write these. So this is the first part represent the rows. So we're gonna reorder the rows. So my data function, the first argument, I'm going to copy this to copy this and put it here, because I would like to have the order that way. If you type only my data, if you type my data, and you left nothing, what are you going to get? You're going to get all of them, all of the observations in the same order as they are. It doesn't give you everything, it just gives you the first 10, because it says we have another 490 more rows. The idea is, what if you'd like to change the order of these? So that's why we put the order function inside the rows. But this is not enough, because the question says we need the data to be sorted by home ownership first, car ownership, then travel spending, and all in ascending or descending order. So first of all, we're going to have not food spent, own home, then my data, another sort. This is for the car ownership. Then my data for travel spent. Decreasing, yes. Then this is going to be my sort. So sort the case based on these. Run. After running this, we are going to get sorted data. Let's look at this. Click on this. So they are sorted. Yes, yes. Then travel spending is the highest, because yes first, then no. So yes, 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 2, 4, 3, 7. Yes, yes, 2, 3. Then goes what? Into decreasing order, right? So it's all decreasing, starting from yes, yes, then yes, no, again decreasing, then where is it? No, yes, decreasing, then no, no, decreasing. So you have now two data sets. The first one is my data, the original one. The second one is the sorted data based on these, right? So the second part says, how much did the first customer on the ordered list spend on food? So let's do this. How much the first spend on food? We have the sorted data. It's sorted already, right? But we are going to look at the first person. The first person. How much they spent on what? Food spent. Food spent. So the first, I'm looking into the table. I have a brackets. In the brackets we have comma. The number before the comma tells you the rows that you're looking for. We are looking for the first row. And the second, or after the comma, we are looking for the variable or the column. Which column we are looking for? We are looking for the food spend. For the food spend. Then, or this is 1, 2, 3, 4, 5. You can type 5 here, or food spend the name. So, just click on this. So how much the first customer spent on food? 3,362. Or you can do here number 5, because you know that this is going to be number 5. Enter this. Oh, hold on. 1, 2, 3, 4, 5. So why did I get food spent? Oh, this is the travel spent. Sorry for this. 4. So we're looking for 4. Food spent 3,362. Or you can keep it food spent. You just write the title of that variable to get any value from the table, to extract any value from the table. If you'd like to get all information about the first customer or the first spender or the first consumer, you can leave this empty. So enter or run it. So we got this guy, the first one, the table, which is case 198. He has home, he owns car, he spends on food this, he spends on the travel like this, right? Good. So we're done with the part A. Let's take part 2 or B. Let me copy this. Part B. Sort the data only by the travel spending in descending order. So we have to do sorting in descending order only by travel spending, how much they spend on. So I'm going to copy this, carefully copy this. So because we're going to do another sorted data, so I'm going to call it sorted data 1. And it says by travel spending. So I'm going to remove all of these. I'm going to sort my original data, my data, and I'm going to use the order function, right? So we're going to order this in a descending order or decreasing order, right? So we're going to get sorted data 1, regardless of the first few variables. Enter. So we got sorted data 1. Look at this one. Click on this. So we don't care about the order of these. We care about the order of this. Look, descending. The maximum number appears at the top. Then the minimum appears at the bottom, right? Then the question says, find the number of homeowners of the first 10 most spenders. or at least says of the 10 customers who spend, let me copy this. Of the 10 customers who spend the most on traveling, how many are homeowners? So we have two parts here. So the question says we need to look at the first 10 customers. We can go and look, right? We can go and look and count, but this is not practical, right? So what we have to do first, we have to look at number of homeowners of the first 10 most spenders. So we're going to use a function called length. Before using the function length, let's look at something. Let's look at the function that we used in the introduction of R called which is a very important function. Now my data is going to be my sorted data one, right? What if I use, let me just show you this. Go to the console a little bit. Let me clean this. Let's use which first. What does which do? Let me use sorted data one on home. So what I'm going to look at my sorted data one, and I'm going to look at specifically the column of the on home. Not only this, I'm going to look at the cases from 1 to 10, the first 10 cases, and this is very important. This is kind of a subsetting. We would like to look at sorted data one. This is not enough. We're going to look closely to the home own, to the own home, sorry. So that's why that we use the $sign and home own. Not only this, I'm going to look at the first 10 cases. Why the first 10 cases? Because the question says of the 10 customers who spend the most on traveling. Because we have them sorted already, so I'm going to look at the first 10 customers. Not only this, I'm going to use a logical statement, because which, if you remember, returns true or false. So I'm going to look at the ones who spend money, so who says yes, who owns houses. I'm going to look at the ones who own houses. How many of them are homeowners? I would like to look at the ones who own houses. From the first 10, how many owns houses? Because we have already these 10 sorted according to their, to their spending on the travel. So how many of these have houses or homes, right? So if you use the which function returns the what? The cases that have homes out of the 10 cases, the first 10 cases. Who are the ones who have homes? Case number 2, case number 3, case number 8, right? But I don't want you to give me the cases, which give you the cases here, right? I would like you to count these. So how many do we have here? We have 3. So I'm going to use, before the which, I'm going to use length, the length function. So the length function give you how many observations do we have? We have 3. So this is exactly what we're looking for. We're looking for, of the 10 customers who spend the most on the traveling. How do we know this? We use the first 10 cases. How we know these are spending the most on traveling? Because these are sorted descending order, right? So these are the top 10 who spends on the travel. I'm looking for those who has homes. Then I said, which are these cases? The cases are 2, 3, 8. Then I'm gonna know how many are these. So we use the length function. So let's go up here. Length, which sorted data 1 on home equals, double equals, it's a logical statement. And I would like to add the first 10. There's no need to look at all of them. So that's why you have to look at the first 10 only. If you did not add the first 10, it's going to give you the length of, people who has homes across the 500. Run the chunk. So we have this. Then the second part says, how many of them are both homeowners and car owners? So now we will be doing the same thing. Again, we're going to count, right? So we're going to count homeowners. We know this. I just copied the previous code. We know that the number of, customers who own homes. At the same time, we'd like to add another argument. To add another argument, we are going to use AND command or AND symbol. So we are looking for 2 conditions now. Consumers who have both homeowners and car owners. So we're going to do the same thing. Sorted data 1, car owners. The first 10 cases Who said yes? You have to use the same letters, capital and small. How do we know? It says here, look at yes or no. Yes, capital Y, ES. Should be matching the character letters. So what does this function tells you? It gives you the number of the top 10 consumers who spends on food on the travel, who have both cars and homes. So enter. We have only one person. We have only one person who has both. And you can validate this. Go look at the data. Which one has yes, yes? Only this one? Yeah, only this one, yes. Which is case number 3, or ID number 198. So this is the second part. Now let's look at part C. Part C, how many missing values are there in each variable? Part C. So how many missing values are there in each variable? So let's create a chunk. To look at the missing values for all variables, what we can do, let's call it missing values. I'm going to use a function called call sums, and I'm going to look at another function called is.na. This function gives you each case contains a missing value or no. Na my data. So na my data, if I just copy this alone, let me copy this and paste here. Look at this. Look at the first one, ID. Do you have a NA or missing value? False. No. False, 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 false. Do you have a missing value in each? False, false. So the places that has missing value is going to be counted as a true. What if I added call? If I have this function is NA, what if I added call names before it? So what's going to happen? Let's see. Call sums. Call sums, look at the column, look at each column, and look at the missing value for each column. So it looks at the names. So ID, for example, how many missing value in the ID? Nothing. How many missing value in the own home column? 3. How many missing value for the third column is 3. How many missing value on the food spend? 0. In the travel spend, 1. So we know now the variables that contains missing values. So there is no need to look at all of the variables, especially when you have like 10, 15 variables. There's no need to look at every one, which one contains missing values. At least you know which variables that do contain missing values. So now I can do what? I can look at the missing values. You can use the print function, by the way. You can use, so this tells you what? Let me add a comment here. So check missing values in all variables. Another function, you can do what? You can display variables with missing values. So you don't want and their counts. Because here it displays everything, all of the variables. Just I care about the ones that are greater than 0. So you can use another function, let's say. You can do this, there is no need. Well, you can print missing values, this variable that we created, missing values. I'm going to only take the values. This missing value actually just contains, it's just a vector, by the way. So we have only one argument inside the bracket parentheses or the brackets. Values, missing values. We need to look at the ones greater than 0. There is no need to do this, by the way. Missing values, where is it? Oh, here, hold on. Missing. So it just shows me the missing value greater than 0. I don't want to show the zeros, so that's why. There is no need to do this step, by the way, but it's just for you to use the print function if you'd like. If you'd like to delete it, you can delete this one. And because now we know the missing values, places it exists on the home, own, or on home, own car, and travel spend. So let's now get cases of the missing values for these variables. I'm adding a hashtag because it's a comment inside the chunk, remember. So we are going to use the which function. So which function in each of them, remember. I'd like to look at the cases, right? So which is.na, my data, the original data. On home has a missing value or missing values, copy paste. I'm going to copy paste. Then on car, then I have the third one is travel spend. So all of these contains missing values. So run this again. So these are the cases. So the first one, case 129, or with the ID 129, 166, 219, no, the cases, sorry. The cases, these are the cases that contains missing value in the home own. or own home. These are the cases that contains missing values in own car. This case contains the missing value in the travel spent. So we know, and we can go and look at them. So the idea is to look at these cases. Do we need to, what to do with these missing values? We'll be talking about this later, but at least you know them now. If you'd like to look closely for these cases, you can do this. So let's look at closely to these. Look closely to these cases. It's my data. We're going to look at the column, so comma, all of the columns, but the row. What rows? C. We need 129. We need 166. We need 219. We need 122. We need 143. We need 256. We need 217. So call these guys, all of them. Now we have a table of these cases with these IDs, missing values. Then you look closely to, if you'd like to change them. He has a home, he has a car. We don't know if this person has a home or no. Is this important to be replaced? Are these important cases to keep? Do we need to take them off? Do we need to take these off as well? Is it something that's going to change in our data analysis? So these considerations we're going to talk about in next chapter. So we did the first few parts. Now let's continue and do the next part. How many customers are homeowners? We did something similar to this. Let me copy these two. How many? So we're going to use the function length, right? So this is part D. How many customers are homeowners? We did something similar. So let's use a length function. Length give you the count. So the function use function length, right, to get the count. And use the function use also which spaces, right? Spaces which give you the cases. Give the cases. So we need the cases, then we count them, right? So we use which inside the length. So we need the length, the which inside my data of what? What exactly we're looking for? The homeowners. Homeowners, we're gonna see which ones are yeses. So how many yeses we have for the homeowners? Length. We have 133. For part E, how many customers are homeowners but do not own a car? So we're gonna have and. So we are going to have and. So let me copy this. We need people who owns a home, and we need people. My data again do not have car. So they said no, they do not have car. By the way, or you can use another thing. By the way. Who said no for the car. So let's look at them, how many they are, 88. Or you can use something else, by the way. You can say not equal, exclamation mark equal, that means not equal. Not equal, yes. So we're looking for the cases who have homes and do not have cars. Who have homes and do not have cars. So these statements are the same, both of them. Both scripts, both codes are the same. So we got 88, 88 for the first one, then the second one, 88. So you can use any of them. Let's look at another case. Let's look at this part. Let's look at the percentage. Let's call it part F. Part F. What percentage, or what is the percentage of travelers who spend above, let's say, $3,000 and own a house, or own a house or home? So we're looking for the percentage of the travelers who spend above $3,000 and own a house, or the ones who own a house and spend more than $3,000. So again, let's look at what? The length, the same thing, length which, let me copy this so I don't, be careful you copy and paste. Let me delete the car owners, we don't need it. And I'm looking for what? I'm looking for the people who own homes. At the same time, they spend, so I'm adding and, they spend on travel greater than $3,000. So how many cases do we have? Incomplete. Why this is incomplete? Let's look at the problem. Oh, another one. Parentheses, then we do. So we have 13 of these. 13 out of 500. You can divide them. So we have 13 who spends above $3,000 on a travel. At the same time, they have homes. But it's not practical to divide numbers. So what you can do, you can just divide this number. You can divide it. You can copy this, for example. You can copy, paste, divide by the length of my data ID. Because we know the ID is, the length is going to give you like 500. So you are dividing by the 500. You can do it. Look, In programming, we can do many things. There is no one way of doing things. There are many ways of doing anything. I'm trying to be simple here. So you can divide these, you get, oops, we have a problem here, length, th. So you have 22.6% of people who spends greater than 3,000 and they have homes. If you'd like to change this, there is no need to have the first one, by the way. By the way, you can call the first one, you can give it a name. You can say this is X, right? Then you can divide X by the length. If you'd like to call the second one another name, so let me call it Y, let's say. Y is this. You can divide X over Y. Does that make sense? So actually you are dividing this over this, or X over Y, right? Or you can multiply this by 100 to get the percentage. So it's 2.5. It's 2.6%, right? We can use a function called cat, which stands for concatenate. So cat. So let's say the percentage. Let's double quotations. The percentage of homeowners who spends on travel above $3,000. How are we gonna get this? We're gonna add comma. So we're gonna add this function, right? Comma. I'm going to add percentages. Sign. Comma. I'm going to add a new line. A new line is /n. The percentage of homeowners who spend on travel above 2.6 is, let's say is here, is 2.6%. So again, the cat function concatenate. We have text, we have functions, so you separate them by commas. The text has to be within quotations. The functions, there's no need to be within quotations. If you would like to go into new line, you have to add another comma, then /n within quotations. So this is concatenate function. So this is everything about the data inspection. We know a little bit about our data, missing values, counts, and sorting our data. So you have at least clue about what you are doing on your data. So this is data inspection. I'm expecting you to do the second example, this one, right? After that, we will be doing the next section, which is data preparation. Thank you.